Hello, how are you all doing? Welcome to a new RocketBot class. Today, we're going to have the last lesson of Level 1, where we'll be building a robot using everything we've learned so far. Alright, so what are we going to do? We're going to make a simple robot, one that interacts with Excel and web commands, and also with email. Alright, what's the goal of this class? It's to bring together all the elements and knowledge we've gained in this course into a single robot, so we can see how everything starts to make sense. Alright, what are we going to look at first? We're going to interact with this form, which is a web form created and developed by RocketBot, where we'll need to fill in information. Notice that here there are fields we'll have to fill out. Where are we going to get these fields from? Basically, from an Excel file. Which Excel file? The Excel file we have here. Take a look. This Excel file has information. It has columns with name, email, phone number, message, and a sending status. We'll see what it's for later. Alright. We're going to extract the information from here to then enter it into this form and then click the send button. Okay, let's get started. First, we're going to start by creating the robot, which in this case will be called my first robot. Remember that here, spaces and special characters are not allowed. Let's add a description. A sophisticated and highly intelligent robot, meticulously designed with the singular and profound purpose of diligently applying all the comprehensive knowledge, every concept, and every intricate detail that has been thoroughly covered and extensively taught within the confines of the classroom environment. And now we're going to start building the robot. Alright, remember that when we need to start a robot or begin a process, we have to understand and know exactly what that process is about. We need to know if it can be automated and if it is standardized. Why these two concepts? Because it's important to understand where the starting point is and where I want to end up. Because obviously, we can't start a process if we don't know what data we're going to start with, what the inputs are, and what the outputs should be. So, as we just mentioned, the input will be the Excel file from which we will extract the information, and the output will be the form where we will have to fill in that form with the information from the Excel. So, the first thing we're going to do is open the form. Obviously, we're going to use Open Browser. In this case, we'll select Chrome, and here we'll enter the URL of the form and click Accept. Let's check that this works correctly. We see that it opens Google and opens the form. Perfect. Now, remember that we need to automate as many variables or variable inputs as we can automate. That is, if I have data that I can use multiple times, or it's easier for me to work with variables so I don't have to keep copying and pasting every time I need to use that information, what I should do is store that information in variables. For example, here I can replace this. Thank you. This with the URL variable, which I don't have yet, but we're going to create it. So here, look, I come here, I copy, or rather, I paste the data, and I put URL and the URL data, which in this case is the form URL, and here in category I put web, just so it's categorized and it's clear what each piece of data is about. Alright, then. Remember that every time we start or open an application, in this case, its DROM or the commands or the default browser application, we need to validate that action by waiting for the object. Keep in mind that this is absolutely essential. It's part of best practices when building a robot. So for that, we go to the page, right-click and inspect. Click on the 3 dots and let's move this bar down here to make it more comfortable. We're going to click on the pointer button to look for an element, and we're going to search for this element right here because that's the one I want to tell the robot to look for. If it finds it, that means the web page has opened correctly. Alright, as we mentioned in the web class, there are differences between XPath and ID. In this case, we're going to use the ID because it's a fixed ID, and we'll paste it here and tell it to look for the ID. Remember here that it should be visible, and it waits for about 10 seconds. We're going to save this result in the variable res, which I haven't created yet, so we'll create it here. And if I run it now, the variable res returns true. Therefore, it has searched for the elements and found them perfectly. Alright, now what we need to do is apply exactly what we saw in the previous class about child robots, where what I do, or rather, the purpose of a child robot is basically to delegate tasks to other robots so that the main robot isn't overloaded with tasks, isn't full of actions. This, in a way, helps me simplify the construction of the robot and at the same time branch out its actions. And if, for example, I know there's an error in the Excel part or the web part, or that it's in a child robot, I go directly to that child robot and look for it there instead of searching through the entire parent robot. In this case, we're only going to use a single child robot, which is to delegate the task of what is called action validation. Therefore, remember that we already have the variable assigned with the result. Now we need to validate. How do we do this? Remember that we have 2 ways. We can put the if statement here with the condition and everything else, or we can move this if to a child robot, which is what I'm going to do, and perform the inverse validation. So I put validate, my first robot. Created robot. And what I'm basically going to do is put the if statement here and set up the inverse validation. Remember, I'm looking for it to return false. Why? So that if it returns false, I come here. And that this robot takes care of, in case it finds that the response was false, this robot will handle closing the browser and stopping everything, because if it's false, remember, if the response is false, it means the browser didn't open correctly, then the whole process is useless to me. Therefore, with the inverse validation, what I'm doing is telling it to check if it finds false, then go inside the if statement. If it doesn't find false, meaning if it's true, it will execute what's in the else, which can be left empty, and the robot will keep running as usual. What will the continuation be? It will simply be that the robot continues running correctly. So here what I'm saying is, I open the browser, validate the response, go to the child robot, and evaluate the response in this case. If it's true, it continues, nothing happens, meaning the execution goes on, and if it's false, this robot stops everything and the robot's execution ends. Alright, remember, this was explained in the last class, but I'll repeat it anyway. Here I'm using a variable called res, which I have created here, right? Why create it here? Because basically this is where I'm working with it, where I'm I'm telling it to take action, to take a value. Now, if I go to the child robot and create it there as well, what the child robot will do is take that variable, which doesn't have any kind of action, it's not playing any role, and it's going to stick with that action instead of keeping the one from the parent. So for that, notice that I called res, I mean the variable res. That's why I don't create it here, so Rocketbot, or rather the robot, will look for the variable here. Since it won't find it, it will go to the parent, look for it there, find it, and take the value that variable has, which in this case could be true or could be false. That's important, because sometimes we think we need to create the variable here even though it's being used in the parent. And what happens is that this variable, in this case res, since it doesn't have any interaction or any kind of action, will always remain empty. That's why we should always take it from the parent. Alright, so let's come over here. If the browser opened correctly, I need to continue with the robot's execution in the process, which in this case will be opening Excel. So I come here, open Excel, and I'm going to do the same thing we did before. I come here, look, I use this and take this data. Why? Because I'm going to send it to a variable. Remember, it's more useful for me to have it in a variable than to keep entering that path. I also create the category so everything stays organized. So here, all I have to do is call path. Here, I assign the result to the variable. That means I have to validate again. Let's test it to see if it works correctly. Look, I run it and Excel opens correctly. So, what should I do? Since I need to validate this action, in other words, since this action is also going to return either true or false, what I basically need to do is also send the child robot here. Notice that the validation setup is already very simple and very quick. And since I've added a new application, in other words, since I opened the browser at the beginning, here I have to close it in case it doesn't open correctly. And now, since I opened Excel, if it doesn't open correctly, what should I do? Close Excel. Alright, so let's keep saving. Perfect. I'd say I've already got almost, maybe a little less than half of the robot done, or actually, about half. Alright, so once I've validated the action, in other words, confirmed that it opened correctly, I need to start interacting with Excel to see how much information it has. Take that information, read it, and classify it. How do I do that? First, what we're going to do is count the rows, right? And here we're going to put rows. I need to open it, then run the rows action. There are 4 rows in the rows variable. Perfect. So, I'm also going to move these rows. Notice that I can also drag and drop variables. So, see how the information for the variables is also getting completely organized. Alright, once I have the rows, what I need to do is read the information that's inside that Excel file. So I go to the read cell command, and what I want to take is from this cell, from this cell to this cell. So I set it from A2 to D4, not from Lados to D4, and I'm going to save this in the variable datos, which it's going to start creating. And what happens here is that I put A2 to D4, not from Lados to D4. This isn't correct, because if this Excel file gets filled with more information, let's give an example. If it gets filled up, there's row 10. It's read from A2 to D4. It's a fixed range. set it to a dynamic range. How do I do that? Basically, I have to tell it to read from A2 to D, as far as there are rows, however many rows it has read, because I'm interested in taking data. Notice how small this detail is, and how much it's going to change my development. So I run it here, and in data, which I'm also going to bring over to the Excel section, I have the following. If I look, I have exactly a list of lists, where the main list, so to speak, has sublists, where each sublist is a row from Excel. Look, the first row is here, the second row is here, and the third row is here. Now, what I basically need to do is go through each row, that is, the list of lists, go through each list to get the information. I'm going to do that with a for loop. Remember, as we saw in the for class, that we have to iterate this. Now, I'm going to iterate over the variable datos. What does datos have? Datos has a list of lists, that is, in each execution of the for, it's going to work. First run, it works with this list. Second run, it works with this list. Third run, it works with this list. Now, I'm going to create a variable now called Veiler. Why? Because I want that every time it works with a list from the main list, it saves it in Veiler. Let's see how that happens. Here we have the item to iterate over called datos, and the variable is going to be saved in Veiler. Notice, if I go to desktop, look for an alert, and put Veiler here. Take a look. What happens when I run the for loop? Remember, the for is going to go through the first element, then the second, and then the third. Look, I set it to iterate over datos but to store Veiler, and it's showing me Veiler there with an alert. Notice that it's the first element of the row. I'm going to click OK. The robot will continue executing the for loop, and on the second run it shows the second row, and on the third run it shows the third one. Alright, that means it's working correctly. Now I delete the alert because I don't need it. Remember that alerts are only useful while you're developing a robot, not in a production robot. Because remember that what alerts do is pause the robot and show a message, and until you manually click accept, the robot doesn't continue executing. In other words, just to clarify, if I have a production robot that runs on a Sunday at 3 in the morning or at 5 in the morning, and it has alerts, I'm going to have to be sitting in front of the computer waiting for it to show alerts so I can click accept. In other words, for me, a human, to click accept. And only then will the robot continue, meaning it will be able to complete its execution, because if I don't click accept, it just stays there paused. So, understand how important it is not to use alerts in production robots. I mean, it's a conceptual mistake to do so. That's why you need to be careful. If it's there, it's perfect and useful, for example, like we just did, to show a message so we can see that we're monitoring or, in some way, to see what we're working on, what data it's giving us, and other such things. That's why we say it's only used in a development environment.